So we are going to prove the following statement. Let's begin our proofs. All right, so we'll start with an easy one, okay? We want to prove that secant x times cosine x equals 1. Now, in terms of your strategy for proving such a thing, you have to know the rules of the game, okay? One rule is you cannot assume that this is equal right off the bat. That is what you're trying to prove. If we assumed this was equal, then we'd be done just immediately, right? Because what we're trying to prove is already proven, yeah? So we cannot assume that this is equal. You might think, well, okay, that's kind of obvious, but sort of what's the consequence of that? And that is we cannot use our properties of equality in these proofs. So like, you can't add something to both sides or multiply something to both sides. You have to work on just one side of the equation totally independently of the other. All right, so like you might be tempted to divide both sides by cosine here, which looks like that will pretty much lead us to our answer. But you can't use that or any other property of equality, because right then and there you're assuming it to be equal and then you're done. So just that's like the one thing that most people will try to do that you just cannot do, okay? Instead of using those properties of equality, which is mostly what you use in geometry, we're just gonna use those identities we wrote on the last page. So we're gonna essentially like pick one side to work with and try to make it look like the other side of the equation. Now, as we go through these, I'm just gonna be giving you sort of tips in general, but I want you to know that all of these proofs are gonna be a little different, and I can only show you so many examples. Some of them are gonna take a little creativity, okay? So, since you can only work on one side of the equation, my first recommendation is to pick the side that looks more complicated. So you've got one side of this equation, which is secant x times cosine x, and you've got the other side, which is just 1. So which side is like clearly more complicated than the other one? The left side. So what we want to do is manipulate the left side in a way that it equals 1. So what we can do with this one is look at our identities, and you might notice that secant is the same thing as 1 over cosine. So we can use that reciprocal identity to rewrite this as 1 over cosine x times cosine x. So I'm just going to rewrite, any of my substitutions I'll do in red, so when you're looking back at this, you can see exactly what I changed. And 1 over cosine x times cosine x, what does that equal? That equals 1. So what we just did is we made the left side look like the right side. And we're done with that proof. All right, let's do another one. These are going to sort of progressively get more difficult. So let's say I had cosecant of theta times, in parentheses, 1 minus cosine squared theta equals sine theta.
The fun stuff.
Oh yeah.
Retest.
All right, which side looks more complicated? Probably the left side, yeah? There's just more going on there. And the reason why I say that is it gives you more to work with. You can always, technically you can go from one side to the other. If these are truly identities, then you could prove it from like the right side to the left side, but it's always easier to go from the more complicated to the more simplified form of the equation. So the first thing I notice here is that I've got 1 minus cosine squared. Anytime you see like cosine or sine or tan or any of those trig functions squared, usually that's a clue that you're going to need to use a Pythagorean identity to rewrite it. So look back at your Pythagorean identities and tell me, what does 1 minus cosine squared equal? Sine squared, yeah. So I'm just going to kind of split down the middle of the equation so I make sure to sort of not do anything to the right-hand side. And I'm going to rewrite this as cosecant theta times sine squared theta. Okay. So I just made a substitution there. Cosecant theta is the same thing as what? Where do you think we want to go with this? 1 over sine theta, good. So this is going to be 1 over sine theta times sine squared theta. And then you can multiply those to get sine squared theta over sine theta. Oh wait, oops. There's just 1 sine theta on the bottom, not 2. So if you had something like x squared over x, what happens? Yeah, one of the x's cancel out, right? Same deal here. If you have sine theta times sine theta over sine theta, one of the sine thetas will cancel out, and you're just left with sine theta, which is what we have on the right-hand side. So we're done. There's nothing really like to box here because you don't have like a final answer. It's just your entire proof is your answer. There's nothing really to circle here. But I like putting the check mark to show that, yep, I did indeed get from one side to the other side algebraically. I've got one more that's a little bit more challenging. Maybe I'll use a fresh sheet of paper for this. And then one last one that will be a bit of a challenge. All right, so for this first one, I'll have cosine theta over sine theta cotangent theta equals 1. Okay, and I want to prove that that's true using all those identities. So there's a couple of different ways you can go about doing this, and that's going to be true for these proofs in general. So like when you're working these out and you're checking the key on the homework, if I've worked it out differently than you, that doesn't necessarily mean you're doing it wrong, because there are going to be different ways of doing this. And that's sort of the cool thing about proofs, is there's not just like one right way to do it. I mean, there's definitely wrong ways to do it, but there's not just like one path to get there. So what do you think? What should we do first here? Any ideas? Well, what would cosine over sine equal? What the cotangent, right? So that looks like that might get us to where we're trying to go, right? So
we need another step.
Yeah, we need another step. What we need to do is somehow split off the cosine and sine, right? So we can do that, right? The way you would do that is to say that this is equal to cosine over sine times 1 over cotangent. Right? Like if I were to multiply those together, I would just get cosine over sine times cotangent. So splitting up a big fraction is definitely something you want to look at to do. And yeah, we're almost done at this point, right? Because what is cosine theta over sine theta? That's cotangent theta.
And 1 over cotangent is tangent.
Oh. And if you multiply anything by its reciprocal, what does that always equal? 1. So yeah, we're done. All right, we don't have a ton of time left, so this last one I'm going to go through pretty quickly, but at least so you have it written down as an example. Let's try one. Any questions on this one before we do the last one? All right. So, see if you can follow along with this one. We've got 1 plus cosine x over sine x equals sine x over 1 minus cosine x. So This one's probably sort of falls into the category of one of the harder ones to figure out. The first challenge is it's not super obvious, like which side I would consider like more complicated. And so in these cases, like you just sort of pick one and go with it. The proof will look a little different if you try to make the left side look like the right side than if you do it the other way. But that's just sort of the game here. So, because we're almost out of time, I'll go ahead and give you the hint on what to do here. And you'll have to do this occasionally, but you need to multiply this. Like if you look at all this, you want to try to, you've got a sine that you have to get up at the top, you've got a cosine you need to get down to the bottom. So one thing you can do, and again, this is just one way you can prove this, is to take the original expression and multiply it by sine x over sine x, which is the denominator. Now what that's going to give me is sine squared x on the bottom. The advantage to having a sine squared x on the bottom is I can rewrite that in terms of cosine. I'm trying to get a cosine in the denominator. So if I have sine squared x, I can rewrite that as 1 minus cosine squared. And so I am getting a little bit closer to what I want. And I'm kind of rushing through this, but there's only really one more step to go, which again isn't super obvious. But I can factor, I can factor this as a difference of two squares and then cancel. That's basically the last step. So practice the homework. We'll definitely work a lot more on these proofs next time. And I'll make sure this is posted online.